Alright, I want to have a look at what I assume is a relatively new area of equations for us, which is called absolute value equations. Now, we learned about absolute value before. And what we learned is that what's inside the absolute value could actually be positive or negative. So if the absolute value of x plus 5 is equal to 8, then that tells me that the absolute value, tells me that x plus 5 could equal either 8 or x plus 5 could equal negative 8. Either of these work. The absolute value of both of these give me 8. So I actually end up with an absolute value equation getting two separate equations. The absolute value is equal to the positive, or the absolute value is equal to the negative. And both of them are pretty simple to solve just by keeping my working out there. But with the two different cases, I get two different answers. So I get x is equal to 3 or x is equal to negative 13. If we sub them back in, 3 plus 5 is 8, and whose absolute value is 8. Negative 13 plus 5 is negative 8, and the absolute value of that's 8. So on substitution they make sense as well. So let's have a look over here. Absolute value of 2x minus 5 is equal to x plus 6. Once again, whatever's inside the absolute value could equal the positive, or whatever's inside could equal to the negative. So we get two cases again. In this case here, again we'll just do like our normal equation solving processes, collecting the like terms together, adding 5 and adding 5, and getting x is equal to 11. Over here we'll do a similar sort of thing, except this time around what we'll do is we'll go 2x minus 5 is equal to, multiply through by the negative, negative x minus 6, which means that then I'll add x to both sides. 3x minus 5 is equal to negative 6, and add the 5 to both sides. 3x equals negative 1, and finally dividing by 3, x is equal to negative 1/3. So I'm getting two answers, x equals 11 or x equals negative 1/3 as my answers. Now once again I'll just check my solution, so I'll substitute 11 back up into here. 2 lots of 11 is 22, take away 5 is 17, and 11 plus 6 is 17, so that works. Taking negative 1/3, substituting up here, negative 2/3 take away 5, negative 5 and 2/3, absolute value of which is going to give me 5 and 2/3. Negative 1/3 plus 6 is 5 and 2/3. So again, both solutions work. Now, checking the equations is good to make sure you get them right, but there's actually a reason I'm checking for these absolute value ones, and I'll show you here. Similar to the last question we did, I've just changed the signs a little bit. And so what I'm saying is that 2x plus 5 must be able to equal to either positive x minus 6 or 2x plus 5 is going to equal the negative of x minus 6. So I'll go ahead and solve them, subtracting the x. X plus 5 is equal to negative 6, x equals negative 11 when I subtract 5. Over here, 2x plus 5, negative x plus 6. Adding the x, 3x plus 5 is equal to 6, subtract the 5, 3x is equal to 1, x equals 1/3. So now I'll go back and check these. I'll get x equals negative 11 and I'll substitute it back up in here. Negative 22 plus 5 is going to give me absolute value of negative 17. This side it's going to give me negative 11 take away 6, negative 17. And you can see straight away this is not a solution. Negative 17 equals absolute value of negative 17, that's positive 17. And it cannot equal negative 17. So this is not a solution. We'll jump across here and take the x equals 1/3 case and put it in here. 2/3 plus 5 is 5 and 2/3. Over here I'll put a third in here. Third take away 6 is negative 5 and 2/3. Same situation's arisen. I've got 5 and 2/3 supposedly equal to negative 5 and 2/3. Not a solution. So just because we set up an equation doesn't mean there's a solution for it. And in fact, what's happening here is if we tried to graph these two lines, we would find that the graph of 2x absolute value, it does this. We haven't looked at this graph yet, but this is the absolute value of 2x plus 5. And this is what the graph looks like here. And the graph of x minus 6, you should know that one by now, minus 6, it's going like this. And you can see that these two graphs are just not going to meet. This one's going to keep shooting up this way, this one's going to shoot up that way. They're never going to meet. And that's what this not getting a solution to the equation has told me, that these two graphs will never ever meet. Sorry, these two as graphs will never ever meet.